Welcome again to another opportunity to discuss with the Children's Academy. In the video before this, we saw the part 1 of this experiment on triangular prism, where we derive all the important formula we need to use while trying to get our readings without touching the apparatus in the exam hall. And now we want to use those formula to see how to make our table out and plot our graph. Let's see how to apply it. So all you need to do is to make use of your calculator. Make use of your calculator and your pen. That is enough for you to do it. Let's see how to do it. The SN means experiment 1, 2, 3, 4, 5. I advise students to put their readings into decimal places. Now, in triangular prism experiment, they will give you the value of your incident angle. Now, while putting it in your table, please don't forget to put the unit of those parameters. If you do not put the units of the parameters, some marks will be subtracted from your marks. So I've put the units now. Now, in experiment on triangular prism, they will give you the value of your incident angle. So the incident angle given to us are 30.00 degree, 40.00 degree, 50.00 degree, 60.00 degree, and 70.00 degree. Let's see how to get our table so that we'll now go into graph plotting. Now, how do you get our D? It is important to note that the first formula we derive says that R1 is equal to sine inverse of sine I all over refractive index. Now, for you to perform this experiment or to derive this, what you need to remember is that the refractive index of triangular prism, I repeat, the refractive index of triangular prism or rectangular prism is approximately 1.5. Is approximately 1.5. That is, this refractive index is approximately 1.5. But I will not tell you to use 1.5 straight. Now, the range of value on your exam fall between 1.48 to 1.52. The further you get your refractive index away from this, let's say you get 1.47, 1.46, 1.45, 1.44, 1.43, 1.0, 0. And all have you. The further you get it from here, from this range, the more small marks might be subtracted from you. So this is enough to be your range of value, because when you add the 2 and divide it by 2, you'll be getting 1.50. So I'll be using 1.48 because I want to use formula method to derive it. Now, I want to make table for the one of 30 degrees. I will say, therefore, my R1 will be equal to sine inverse of sine 30 over 1.48. Sine inverse of sine 30 over 1.48. Sine 30 is 0.5. I'm using my calculator now. 0.5. I will now say sine 30 is 0.5. 0.5 divided by 1.48. That will be giving me 0.3378. So what I will now put is shift sign. Shift sign means sine inverse bracket 0.5 divided by 1.48. So I'll be getting my answer to be equals to 19.75 degrees. I repeat, all you have to do if you do not want to do it using rigorous process, all you just do is you press shift, press sign, it will give you sine inverse, open bracket, press sine 30, that is 0.5, sine 30 is 0.5 divided by 1.48, close the bracket. That will be giving you 19.7451981. I will approximate it to 19.75, that is to 2 decimal place. I will now have my R1 to be equal to 19.75 degrees. I will now come again. What about my R2? R2 says that the answer is 60 minus R1. Then what is R1? 19.75. So I'll be having my R2 to be equal to 60 minus 19.75. So the answer will now be 60 minus 19.75. That will be giving you 40.25 degrees. I'll have my R2 to be equal to 40.25 degrees. Then I will remember that my E, emergent angle, is equal to sine inverse of refractive index times sine R2. And our refractive index, the one we took, is 1.848 times sine R2. That is sine 40.25. Sine inverse of 8. Let's get it. I will press my calculator, shift sine. I will get sine inverse bracket, shift sine bracket 1.48 times sine 40.25. I'll close the bracket. That will be giving me 72.99 degrees. So I'll be having my E to be equal to 72.99 degrees. I will say okay. Then that goes to D. What is the formula we are to use to get the D now? We remember that D is equal to I plus E minus A. Now, in this experiment, we have different types of triangular prism. So the triangular prism we are using, that is mostly used, please, is the one of equilateral triangle, the one that is carrying equilateral triangle. And at this, we now have that A will be equivalent to 60 degrees because each of the sides of the equilateral triangle is 60 degrees. So what we will do here is that we now say 30 plus 72.99 minus what? 60. We now use this formula because we derive it in that video. So try to watch the first part of this video to see all the formulas we derive and note it. So we now say 30 plus 72.99 minus 60. That will be giving you 42.99 degrees. Having that, we say that D is equal to 42.99 degrees. So we'll have here to be 42.99 degrees. We say we are done with the first part of D. Then for the second part, we have to get our E, and we said that our E is equal to what? 72.99. Then our D minus E. Our D minus E. That will be giving us 42.99 minus 72.99. That will be giving us minus 30.00. Now your A, since our A is taken to be 60, that means the range will fall between 59 to 61, knowing fully well that the average of it will be giving you 60. So we write 59.00, 60.00, 61.00, 59.00, 61.00. When you take the average of it, it will be giving you 60. Okay, then we'll come to the next one, 40. We say that when I is 40, we say our R1 will be equal to sine inverse of what? Sine 40 over 1.48. So what we do is we now say shift sine bracket sine 40 divided by 1.48. We'll close the bracket. That will be giving us 25.74. Okay, so what we now do is that we say our R1 for the next one is 25.74. Then our R2 will be equal to, we say from our formula also that R2 is equal to 60 minus R1. Then 60 minus what is our R1? 25.74. 25.74. Then we are saying 60 minus 25.74. That will be giving us 34 equals to 34.26. We now say this is 34.26. Then we come again to get our E. We now say that our E is equal to sine inverse of refractive index times sine R2. Sine inverse of refractive index times sine R2. What are we going to get? We now say sine, shift sine we now say shift sine bracket 1.48 times sine 34.26. That will be giving us 56.43 approximately. So we say our E is equal to 56.43 degrees. Then after getting your E, we now go straight to get our I and our D. Our D is equal to I plus E minus A. That means I is 40 plus 56.43 minus 60. That will be giving us 40 plus 56.43 minus 60. That will be giving us that our D is equals to 36.43. Okay, I will write 36.43, then 56.43, then D minus E, D minus E, 36.43, 36.43 minus 56.43. That will be giving us 20 minus 20. Okay? Then we'll go again and we now save the 50 on when I is 50. When I is 50, R1 will be equals to sine inverse of sine 50 over 1.48. Okay? That will be giving us, you press it in your calculator, shift sine bracket sine 50 divided by 1.48. That will be giving us 31.17. So R1 is equal to 31.17 degrees. Then you now get your R2. R2, you minus it from what? R2 equal to 60 minus R1. Therefore, R2 will be equal to 60 minus 31.17. 60 minus 31.17. That will be giving us 28.83 degrees. So we go to the next one, that emergent angle is equals to sine inverse of refractive index times sine R2. And refractive index 1.48, sine R2 is 28.83. So we'll be having it this way. We now say shift sine bracket 1.448 times sine 28.83. That will be giving us 45.53. Okay, then we say our E equal to 45.53. Then what will be our D? Our D, from the formula D equals to I plus E minus A, we say that it is 50 plus 45.53 minus 60. Let's get 50 plus 45.53 minus 60 plus 45.53 minus 60. That is D equals to 35.53. So we'll have it here, 35.53, our E 45.53, and our D minus E, that will be giving us minus 10.00. Okay, we go to the next one. Next one, we say that R1 will be equal to sine inverse of sine 60 all over 1.48. Shift sine bracket sine 60 divided by 1.48. I'll be getting it to be 35.81. R1 equals to 35.81 degrees. Then I'll go to the next one, that is R2. R2 equal to 60 minus 35.81. 60 minus 35.81, that will be giving us 24.19. We have our R2 to be equal to 24.19 degrees. Then we go to E. How do we get our E? We say from our formula E equals to I plus I. From our formula E equals to sine inverse of refractive index times sine R2. So we'll be getting our E by saying shift sine bracket 1.48 times sine 24.19. That means our E will be equal to 37.33 degrees. E equal to 37.33 degrees. Then how do we get our D? Since we are to get all this from our experiment, we also say that our D equal to I plus E minus A. That is 60 plus E, 37.33 minus 60. That will be giving you D equal to 37.33. So we have here 37.33. So you don't need to be putting degrees on top because you have put degrees already. Then you now have this 37.33, 0.00, and you have here 59.00 and 61.00. Okay, coming to the one of 70, we say that our I is 70 degrees. Then, since our I is 70 degrees, our R1 will be equal to sine inverse of sine 70 over 1.48. So we say shift sine bracket sine 70 divided by 1.48. That will be giving you equals to 39.41. So R1 equal to 39.41 degrees. We will now get our R2 by subtracting R1 from 60. R2 equals to 60 minus 39.41. R2 will be equals to, we'll have it to be 20.59 approximately. Then we get our E by saying that E equals to sine inverse of bracket 1.48 times sine 20.59. I will now say shift sine bracket 1.48 times sine 20.59. That will be giving you E equals to 31.36 degrees. Then we'll come to our D. I will say that our D is equal to I plus E minus A. That is 70 plus 31.36 minus 60. That is 41.36. So we have D equals to 41.36, 31.36, 10.00, and so on. So we have succeeded in making our table just using our calculator. Please, while using the calculator, don't use sales-gear calculator. Try to use scientific calculator. You can see I was busy using sales-gear calculator and it delayed me at some point in time because I'll be trying to use some information I know from my four-figure table while pressing with it. So please use scientific calculator, your pen and your graph sheet and your paper. Do your readings, get your readings, plot your graph and get out of the hall. With that, you are done with everything. So, as you enjoy my video, I thank you for being part of my channel. Just feel free to share it with your friends. Don't forget to click subscribe button and turn on your notification button so that you see more videos I'll be posting on practical physics. Remember, we have succeeded in getting the table of values. We will see how to use this table of values to plot our graph. Okay, so we'll go into graph plotting in the next video. Please see the next video as we plot the graph. After plotting the graph, we'll answer these questions. Thanks for watching the video.